Hi, I'm Gary Norton. I wanted to take a couple minutes and revisit a concept that I covered before on the channel, but I'm not quite sure I did a good enough job explaining it. A couple months ago, or actually a month ago, I posted a video on the AI tokens and context window. And for those of you that watched, I think the concept made a little bit of sense, but I didn't explain kind of some of the more nuanced versions of context and tokens. So I want to get into that today, but I'm only going to start with tokens so that I can reference this video exclusively. And then maybe after this, I'll probably create another video right away and show it. But it has to deal with the AI Tokenizer app. Now, tokenization is the way that an LLM breaks up the text or information you give it into bite-sized chunks that it can use. Every LLM is going to do it different. So even within OpenAI, if you look, their tokenization for GPT-4o and 4o mini is different than the same tokenization model they used for 3.5. And if you go all the way back to GPT-3, it was different even then. Other providers do the same thing. So it's not necessarily that you understand exactly how it's going to tokenize as much as you understand what is being tokenized. Now, in short, tokenization just takes the content that you enter in and it breaks it up into smaller bite-sized chunks. In many cases, it's going to be whole words, but not always. Sometimes it will be symbols or even parts of words. What I want to showcase in this case here, if I bring up some of this, is that we've got our general text here, but if you look down at this tokenization, I do want to mention that the colors here have no bearing to one another. So purples aren't related to purples and yellows aren't related to yellows. They've just used kind of a rainbow pattern here to show you where the word breaks happen. But if you look at the first part of the line, the words just imagine living life are broken up like you would think. They're just words. And that's how it is in most cases, probably about 70% of the time, maybe 75% of the time. But if you actually look over here at the word dreadfully, you see how it split that in the middle? And you'll notice that spaces right here between over and 50 got its own special token, but other times it didn't, because like right here before the T, that was part of the word to. I'm not really sure how to explain the logic behind how tokenization works, other than the fact that it bases it on a pattern that it recognizes, and it uses that to help generate future text. If you look down here further on some of these symbols, you'll see that this parentheses here with a space was a token, and this parentheses here afterwards was its own token, but it didn't have a space. Now, if you actually come back in and switch this over, you'll notice that we're at 70 tokens for 323 characters. Even if I just switch this to GPT 3.5, you'll see that our token number changed. And the words don't always break down in the same place. They're similar. If I go back to GPT-3 Legacy, you'll see that it even gives a different version of tokenization. And in this version down here, if you look at it, it actually put, again, the parentheses outside and broke the words specifically, but by and large, that's what tokenization is. It's just going to take the words, break it down into little Scrabble pieces. And the reason you need to understand this is because almost everything when in LLMs, particularly when you're using APIs and pricing, refer to tokens. You're paying for the number of tokens going in and the number of tokens going out. And so it doesn't really work out to words. Like I said, it's about 75%. But in general, if you're, say, doing 750 words, you probably plan on about 1,000 tokens being used. That's it. That's all I wanted to show you here. Now I'm actually going to create another quick video on another topic that I think you need to understand on how these tokens relate more directly to the context window. And then I even want to explore a concept called retrieval augmented generation, or RAG, because that has a big impact on tokenization as well. Thanks for your time. I appreciate it.